In section 6.4, we're going to talk about nonlinear functions. So we're going to be comparing linear and nonlinear functions. So let's start out with your vocabulary. The graph of a linear function shows a constant rate of change. A nonlinear function, that is your vocab word. A nonlinear function does not have a constant rate of change, so its graph is not a line. So make note that a linear function, as you've done before, makes a line. A nonlinear function does not make a line. So it's showing a constant rate of change and not showing a constant rate of change. So let's start with our first example. So example number 1, write this down. Does the table represent a linear or a nonlinear function? And then you have to explain. You have to prove why. So let's start with A. Let's look at what's happening in our graph, or in our table. Our change in y goes from 40 to 32. Well, that's subtracting 8. And let's see if that continues. 32 minus 8, 24 minus 8. So each time our change in y is constant. It subtracts 8 each time. What happens to our x values? Well, they add 3 every time. So our slope is negative 8/3. It's a constant rate of change. So you have to explain this. Here's how you would explain it. I want a good reason, not just a couple words. I want a sentence or two. So first I'm explaining, as x increases by 3, y decreases by 8. Therefore, the rate of change is constant. It is linear. And let me change the spelling error here. So it is linear. So we've just proven that A is linear. So let's look at part B. In part B, our table has x and y, and let's look at our x's. Our x's go from 1 to 3, 3 to 5, and 5 to 7. Each of them add by 2, so therefore it's a constant rate of change. So y, though, 2 to 11 goes up by 9. But 11 plus 9 is 20, not 33. So this increases by 22. Y increases 33 to 88 by 55. This is not a constant rate of change. So how would we explain this? So we can say, as x increases by 2, y increases by different amounts. Therefore, the rate of change is not constant. This is not a constant rate of change. I mean, the x is constantly going up by the same number, but y is not. Therefore, it's not constant and is not linear. Example 2. Does the graph represent a linear or nonlinear function? Explain. So A and B, make a rough diagram or a graph of this in your notes. You don't have to use graph paper, but just draw your axis and draw a line that's kind of curved in A and then a horizontal line in B. So if you look at A, does the graph represent a linear or nonlinear function? Well, knowing our key idea, a linear function makes a line, a nonlinear function does not. So if you look at A, we can see that it curves. Therefore, this graph is not a line. Therefore, the function is not linear. So we're going to call it, this answer would be non-linear. So since it's not linear, we're going to call it nonlinear. So that's our vocab word, nonlinear function. So B. B, does it make a straight line? It sure does. So our answer, the graph is a line. So the function is linear. So here our answer would be linear. So once again, nonlinear function does not make a line. A linear function does. In example 3, the question asks, which equation represents a nonlinear function? So we're given 4 choices, A, B, C, and D. We want to pick the one that does not form a line. Now this should be fairly easy because if we just go one by one. If you look at y equals 4.7, absolutely that's going to make a line. That's going to be a horizontal line that crosses the y-axis at 4.7. So that's not our answer. B equals, and you're like, pi x. Oh, maybe, we'll see. C, y equals 4 divided by x. D, y equals 4 times x minus 1. So here's what we want to think of. We have to think, which equations can I write in slope-intercept form? Y equals mx plus b. A is already in y equals mx plus b because it's solved for y. And then we have mx, and the slope is 0, and your b is 4.7. Choice B, y equals mx plus b. Absolutely. M is pi. X is there, and b, there's nothing there, it'd be 0, so it's not b. Let's go down to D. D, you have 4 times x minus 1. Well, you could distribute and get 4x minus 4. Well, that's in slope-intercept form. C is not our answer, and here's why. Y equals 4 times x. In order to get rid of the x, the opposite of divide x, you'd have to times x, and that gives you xy equals 4. Well, that doesn't help us. There's nothing here that we can write in y equals mx plus b form. So therefore, C is our nonlinear function. Example 4. Account A earns simple interest. Account B earns compound interest. The table shows the balances for 5 years. Graph the data and compare the graphs. So we have to first graph the data. So I'm going to make my x-axis, which is t years, go by ones. And account A and account B both start at 100, so I'm going to do a break. And I'm going to start out at 100 here. So 100, and since I only have to go to 160, I'm going to go by tens. 110, 120, 130, 140, 150, 160, 170. And we know this is balance in dollars. Our y, or x, which is t, which represents years, that's time, we're going to go by ones. And this is years. So I'm going to use blue for account A. So if we do 0, 100, we do 1, 110, 2, 120, 3, 130, 4, 140, 5, 150. We draw our line. Okay, now we're going to do account B, which I'm going to do in red. So we start at also 0, 100, then we go to 1, 110, and then we go 2, 121. Then we go 3, 133, and then 4, 146, and then we go 5, 161. You'll notice your graph is going to do that. So we have to compare the data. Now, just by looking at it, you should be able to look at account A and realize that it increases by 10 every time. Therefore, account A would be linear because it makes a line. Account B is not linear because it starts curving upward. This increases by 10, this increases by 11, this increases by $12.10, and so on. It does not increase at a constant rate. So we can say that account A has a constant rate of change and is linear. Account B does not have a constant rate of change and therefore is nonlinear.